taking you walk through what you need to include in your report for the final course project for bio. So under the introduction section, I just wrote a brief little introduction paragraph. It's kind of silly and I am thinking about deleting it, but that's okay. Then also under the introduction section, you should state your hypotheses. I think Rose said we only needed to have 4 hypotheses. So what I did was I kept my, I wish I had like a little pointer or something. Can I do that? That's okay. So I kept my wobble bot survival rate hypothesis, basically just saying it's gonna, if it survives, it's gonna reproduce and pass on its traits. And then for the monohybrid cross, since it was autosomal, we just state that if the trait is autosomal, then the F2 generation, blah, 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 you can read. For the monohybrid crossover 2, the only difference is that the trait is sex linked. So it will display a different phenotypic ratio. And I just included some information about why that is. So that's monohybrid crossover 2. Next hypothesis is for the dihybrid crossover 1. Once again, these were both autosomal. And then lastly, this is the tricky one, dihybrid crossover 2. And the reason it's tricky is because one trait, which is tail shape, is autosomal, and the other trait, leg texture, is sex linked. So I will include a little bit more about that later. But basically, this phenotypic ratio should be displayed in this order. And that's because that's the way it is. So hypotheses, then background information. All this is just kind of restating the like experiments that we did throughout the course with the Wobblybots. As you can see, I wrote 1, 2, 3, 4-ish paragraphs. I don't think you really need that much, but I don't know what exactly they're looking for. So I did write 4 paragraphs for background information. And then this is the important part that I think Stu really wanted us to kind of highlight. It's the methods. So basically all this is saying what we did throughout the semester and like basically just kind of summarizing the Wobblebot project. So as you can see, he also mentioned that he explicitly wants the method section bulleted. So I started with the initial generation process, which were P1 and F1. Oh my Lord. And you can read that if you want. I'll also send this document to you all along with this video, hopefully. F1 creation, phenotypic analysis. I honestly am just kind of talking in these things. I'm just talking to talk. So data collection, we did that. We wrote everything down, blah, blah, blah. Chi-square, same thing. Wrote everything down. Then, I don't know, we noted the survival rates for the Wobblebots. It's literally just, this whole thing could be summarized in like 2 sentences, but for the sake of word count, I made it a bunch of bullet points. Don't forget bullet points, that's important. All right, now for the results section, all you need, well, I say all you need, it's a lot of papers. Monohybrid crossover 1, this was the tail shape, okay? It should look like this, and then you should have a short summary at the bottom of each sheet. Still monohybrid crossover 1, summary at the bottom of the sheet. And I'm pretty sure Stu wanted to emphasize the point that in this summary, you shouldn't state whether or not it supports the hypothesis that you stated at the beginning. So that was monohybrid crossover 1, and then this is the chi-square cross for that monohybrid cross. Blah, 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 it's all dandy. He also, I'm pretty sure, wanted us to erase this where it says like hypothesis accepted or rejected. He wanted us to erase that thing. Don't quote me on that. I don't ever pay attention to what he says. All right, monohybrid crossover 2. This is where it gets important. We did this for our IDR for the first report. So you'll copy it, literally copy and paste the monohybrid cross from that and the chi-square test. So this is important. This chi-square test, the hypothesis was rejected, which means basically that the trait is not autosomal. So then you just gotta put a little blurb in here saying because it was rejected, that means it's sex linked. And then you just copy and pasted all this stuff from your first report. And then all of this is new. So it's still monohybrid cross number 2, but it's a new, with the sex links and the X's and the Y's and whatnot. So you do that, blah, blah, blah. Yep. Same thing. Monohybrid cross number 2 still second part of that chi-square test. Now you change your hypothesis. If this trait is sex linked, then it'll do the greater than 0.05 or whatever. Now you can see it's accepted and just put a little blurb at the bottom that it supports the genetic model distribution sex linked. Yep. Okay, this is also new from the IDR. It's dihybrid cross number 1. Luckily, these are both autosomal, so it's basically just what we did in lab. Lots of R's, lots of U's. Kind of sounds like a dog barking. Summary. Part 2. Lots of stuff. Make sure you put the numbers in from the FCP guideline document. Then just a little blurb about that's how it is. Chi-square test for dihybrid cross number 1. All dandy. Woohoo. Okay, this is where it gets tricky. Pay attention. So for dihybrid cross number 2, this is where what I'm doing is not technically correct. So what Stu and Jean want us to do is they want us to do this entire process with assuming that it's autosomal for this second dihybrid cross, but I'm not an idiot. So I know that Stu was trying to trick us and made the second dihybrid cross sex link. So what you're going to do, if you want, is go through this entire process of assuming it's autosomal for these traits, but I frankly don't have time for that. So I didn't. So then what I did was I just frankly guessed which trait would be auto or sex linked, and it worked the first time. So the sex linked trait is leg texture. That's important. So then if you choose to go about it like this and you've done the autosomal cross, and then obviously your chi-square test will be rejected, then hang on, let me think of words. The rationale you would use to like guess which one of these traits is sex linked is you would say, okay, the females, basically people with hairy legs. So see this H in the middle means hairy legs. Hairy legs, hairy legs, hairy legs. So how do I explain this? So the 3:1 to 3:1 to 3:1 to 3:1 ratio stays consistent with the change of leg texture, right? It doesn't have anything to do with smooth or curly hair, or tail. So, sorry, I'm trying so hard to think of words. Also, I just think this is wrong. There we go. All right. So yes, this is the kind of the trickiest part. So once again, you may have to, if you want full credit, which I don't, I'm so over this class, you might have to do the whole process and prove that it was rejected, and then go through why the leg texture is a sex linked trait, and then redo the entire thing with the leg texture being sex linked in your Punnett square. Then this is the chi-square test for that, and I just put little symbols, which I think is good, and basically change the hypothesis. If this trait is autosomal and this trait is sex linked, then blah blah blah, and then it'll be accepted. Woohoo! and then you're done with all of your crosses and chi-square tests. Okay, so that all of this information has to do with the randomly assigned scenarios in the guidelines document. And these are all for Rebots, right? Not Wobblebots. So that's important. And then this stuff is all for our Wobblebots that we did in class. This was all filled out in class. Make sure yours looks exactly the same. So chromosome 1, summary, chromosome 2, summary, chromosome 3, summary, and maybe if my mouse will work, chromosome 4, summary, and then you move on to your conclusion and discussion. So there's three parts of this, I'm sorry. First part is discussion of your hypotheses. Basically just restate everything and say why it was right or why it was wrong. I'm not wasting time with making wrong hypotheses. So I just made all mine right from the beginning and explaining why. Okay, so that's part one, is restating your hypotheses. Next is those summary questions that he gave on the guidelines document. I think there's 6, and he said not to number them and not to restate the question, but just to answer them in paragraph form. So there should be 6 paragraphs, 1, 2, 3, 4, 5, 6. Beautiful. And then the very last part of the entire presentation or the entire report is error analysis. Basically, you just have to state 2 reasons why there could be errors in any of our data. Obviously, you can include the fact that Nolan almost messed up our entire project during the last lab. I think it's funny. Who knows if Stu will find it funny. But yes, I have 28 pages at the end of mine, which is a freaking lot. But that is everything you need to include in the FCP report to be submitted before Sunday at midnight.